So today I'm going to show you how to assemble parts in onShape using the FTC library, as well as some best practices and other tools. Prerequisite you should have computer, obviously. You don't need to download any apps. This is all online. An onShape account, if you're a student, that should be free, and access to the FTC parts library, which I think should be linked somewhere around. But anyways, let's start with how we got to this assembly. You always want to try to break bigger components down into assemblies. That way you could reuse them whenever. These wheels that you see here, well, they're an assembly of multiple parts, and because we use these parts 3 other places, I've opted to making them their own part assembly rather than assemble 4 individual parts or create one or import a bunch of parts into the assembly and then copy and paste them later, because you then have to copy and paste your features, your mates and your the other features. We'll break it down to be a little smaller. So let's start. So first things first, what we're going to want to do is we're going to want to create these Omni wheels. Now, if you were to go to the goBilda site, you'll see all the parts that you'll have to work with, but we know we're building an X drive, so we need our wheels to be holonomic. We can't use mechanism wheels; those are vectored in specific directions. So we need Omni wheels. So I opted for 96 millimeters. No particular reason. General thing to keep in mind: smaller the wheel, the better your acceleration. So keep that in mind when building out your chassis. So anyways, you can see that the Omni wheel itself, it's only one part, but we have 2. And the reason why we have 2 and we stack and sandwich them together so that they could carry more weight rather than having all that weight on the one wheel. It also helps with just general movement on the field when you have the 2 Omni wheels rather than the one. What I want to do is I want to create a new part. So I will go to my create part assembly by clicking this insert new tab. I have my assemblies or I have my smaller assemblies organized into folders, but you don't need to be as organized, but that's how I do it. We're given this blank canvas. In here, we're going to want to insert parts. So you click the insert button, then you go to that FTC robotics part users. If you've been let into the group, go to goBilda. They have parts for other manufacturers. Unless you know what you're doing, stick to one manufacturer, and chances are your mentor will tell you which manufacturer to stick to or which parts you're ordering from. If you know what you're doing, then you could use whichever you want, but for now we're using goBilda. Then we're going to go to motion. There should be a wheel section, wheels and tires, Omni wheels. We have our 96 right here. So one nice thing about this library is it's very well organized, much like how you'll find it on the site. So we went to motion, we went to wheels and tires, and then we found our Omni wheels. That organization is still here. Once we could see motion, wheels and tires, now Omni wheels. And then we have 96. It tells you very much to not use these parts, and the reason why it's telling you that is because it's the parts that we've made are an assembly. We want to use the assembly, not the part studio that's found underneath the part. That way everything comes nice and assembled, and we don't have to worry about constraining the individual parts. So I'm going to insert 2 wheels here. Can't sandwich the wheels together just yet. A lot of the times if you're trying to do something, the site itself will have some insight pages, which also kind of tell you which parts you could use to do a quick assembly. Mind you, if you know what you're doing, you kind of have an idea as to all the parts that you need. So this may not be applicable, but if you're a little lost and you're trying to do a quick assembly, the insights really help. It kind of just also shows you how some of these parts are supposed to interact with one another. I need a pattern spacer that's 4 millimeters in length, a sonic hub, screws and washers. So let's go find those. Let's check under structure, pattern spacers, very long. 1504s. This is a 1504 3240. It's a part number, so we can see the part 1504 3220. So go back here, insert that. Then get some screws under hardware. Here's the screws. I'm going to use button head screws rather than the bolt heads because I want to minimize or what's extruding outside of my frame perimeter. So they recommend 30 millimeters in length. So I'm going to find some 30 millimeter M4 button head screws. Here we are. So that's one screw for now. I'm also going to get a washer. So I'll just opt for this one. What else? We also need a sonic hub. And I think that's under motion. Maybe it's not under, oh, there it is. Hubs. Sonic hubs. We want a sonic hub that is the bore size of the shaft itself that we'll be mounting onto. And I know those Rex shafts are, 8 millimeters right here. So there's that. We should have all our parts according to this diagram. So now it's time for assembly. I'm going to start with the outside and work my way in. Doesn't really matter. I like to keep organized, so outside in. So I'm going to start with the fasten mate. What a fasten mate does is it joins two parts at the mate connector. So if you kind of hover your mouse over a part, you can see all the features and therefore like all the natural mates that it'll make just by having that, or just by the geometry existing. Mind you, these screws have a mate connector that connect it at the head of the screw, like right at the base where the threads start. That way you don't have to kind of finagle with it and select it. So I'm gonna click on that mate, join it with this open hole, and boom, we have a screw with the washer connected. Very simple. We now kind of want to continue onwards by joining the screw into one of these holes, then connecting the pattern or the pattern spacer to this other one, and then to the sonic hub. So what I'm going to do is I'm going to connect the bottom of this washer like so into one of these holes. Now, mind you, these are slotted a bit, so you're going to want to select the inside part of the slot rather than the center part. So we select that, and notice how our washer is kind of on the inside. We want to flip that. So now it's on the outside. When fastening parts together, or at least when assembling, it doesn't have to be a fasten. It could be any sort of constraint or mate that you see here. It only works with the two parts that you have selected. So mind you, I have the washer face selected and the wheel, but we know that the washer is mated to the fastener. We could fix that, or it'll fix itself automatically once we put the mate in. It kind of resolves the geometry afterwards. But if you kind of want to solve the assembly for now, you can hit solve and it'll show you where we're mounting. So there's that. Now we have our one screw with the washer mounted to the wheel. So one thing to keep in mind when assembling things, it's not always true to form. Sometimes it is, in the sense of, oh, this screw could fit through this washer, which could fit through this hole, which then fits through this part. Sometimes that works really, really well. A lot of the times you'll run into over constraints or really trying hard to make it fit. We're going to want to cheat in some cases just to make our life easier. And we could kind of confirm afterwards that our assembly is working as we expect it to. I'm going to join this pattern spacer, like the main hole of the pattern spacer, to this hole right here. Flip it. And we could see that it looks like it's working. and it'd be, or the screw itself would be going through the threaded parts. We don't need it to go through the threaded parts because it's just a spacer. So we can offset it by clicking this tool right here and then rotate it on the Z axis, because that's that axis that we want to turn it on. We're going to want to shift it like 45 degrees. And so you can see here now that it's going through the smooth part, the smooth holes rather than the threaded holes. It looks like it fits fine. I don't see any like weird collisions. It looks pretty good to me. So I'm going to solve that fasten. Then we're going to finish up our wheel assembly by joining the main hole again over here. You can see here that those parts are disassembled, but when we solve it, it all works out. What we kind of want to do is we want to make sure that the parts or the wheels themselves are a little offset. So rather than having both of these taller round parts connected together, we want to make sure that they're a little off, if that makes sense. Oh, hold on. Let me retry that. So take that fasten. Right here, and we can see that it's kind of off by 45 degrees. So we'll probably need to shift it another 45 degrees on the Z axis again. Solve. Yeah, that looks good to me. So they're 90 degrees separated. We can see that goBilda on one side is on the right side of the wheel, and this one's on the top side. But, I'm going to constrain that there. And then to finish up, again, we're going to cheat one more time and do a fasten on this part of the face and join that over here. Should see that the screw head starts poking through the back of the shaft, and notice that it's threaded, so we don't really need to cap it off with the nut or anything. We'll just kind of thread in there, and the actual spacer itself will keep them squishing together. So there we go. We got part of our assembly together. For the sake of completion, if we're trying to get like a bill of materials together, we're going to want to CAD all of our parts, unless you're very confident in exactly what pieces you need, as in how many screws and so on. Or like if you don't really care about how many screws you need and you're just mass ordering thousands of screws, then you probably don't need to worry about screws. I'd like to put some screws in my assembly, not for all the parts, but quite a bit of the parts, so that I know the sizes or the length of screws that I need, not really the quantity. You could probably do a big guesstimate to figure out how many screws you're going to need, but you don't know the length of screws that you need. So it's always good to CAD at least one screw. For the sake of completeness, we'll go about finishing off this CAD. So what I'm going to do is I'm going to select both of these parts, hit Control C, and then Control P, or Control V. Control C and Control V 3 times, and we have copied our screws successfully. And you can see it copies it with the screw in the washer and the constraints intact as well. Now to finish off, we are going to fasten that washer face to the 4 other parts of our assembly. Flip that. Oh, is that on the right side? It is. Constrain. Same with number 3. So sometimes you may not be able to. Sometimes you get lazy and you don't want to change the orientation just to hit the centerpiece. So what you could do is when you figured out like a point that you want, mind you, you can see those white dots there, the points that you want to select, and you may not get the exact point that you want at all times, unless you're like facing it head on. Rather than kind of fiddling around with it, you could hold shift to isolate your that feature itself, and then you play with the control points by moving your mouse around. So that's hold shift on a feature when you see a point that you want, and then you move your mouse and left click to select the part that you're, or to select the connector that you want to mate to. So solve that, and then last one. Screw to that inside right there. There you go. So we got all of our fastens together, and if we're really looking to check to see if everything's all good, we could hide this part real quick, and we can see that it's going through everything. Looks pretty aligned to me, and we could bring it back by pressing Control Z to undo the last action that we did, or we could find the part itself here and hide it or unhide it. So anyways, that is a real quick assembly of our wheel. Let's do some further optimizations, because sometimes less is more. You can see here on the side we have all these fasten mates. If you think about how we use this wheel, all these parts are essentially moving together in a group. They don't rotate independently of one another. We know that they're all going to be fastened together. So what we could do is we could select all these parts and then hit the group button up top right here. And so this will put it all into a group. Mind you, if you have a bunch of parts grouped together, you're going to get an error with your fastens because they're all a part of a group. So after you've grouped your parts, you then want to delete all of these fastens. And we can see that they're grouped, but there's still an issue. And this issue has to do with our Omni wheels. So what we're going to want to do is we're going to want to preserve, or we want to group everything but the Omni wheels, and then leave the fasteners that connect the Omni wheels to the spacer in the middle. So, and this is much easier to kind of work with since we know that it's quite organized. So we want to keep fastener 3 and 4, but everything else can go. All right. And then we go back to the group and we get rid of the Omni wheels from that group. And we can see that we now have a nice clean connection where that inner part is all grouped together. And we have our 2 fastens and three mate features. Life's a whole lot more simpler this way. And we could then play around with our fastens by rotating it about the degrees. But yeah, I guess that's a good tip. Just keep it simple, keep everything nice and clean. Don't have a bunch of fasteners in your assemblies or your parts or your constructions, because it'll get really, really messy. And if you're, let's say you're wanting to control the Omni wheel's angle, it's much easier to do so when you could find it with the one fastener. Mind you, you could also label every fastener, but you don't need to do that. That's too much work. And just to kind of make things a lot cleaner, we're going to hide these mate connectors, and we can see that we have this wheel assembled. So I'm going to rename this Omni wheel. And there, we have our Omni wheel. Looks no different from the one I assembled prior to, but you know, now you know.